Brandon Lewis here of Embedded Computing Design, and I'm here at the Somnium booth at NXP's FTF 2016. I'm here with Dave Edwards, who's the founder, CEO, and CTO of Somnium, who's a UK-based tools company. And we've just been talking a little bit about what are some of the biggest bottlenecks that people working with MCUs or MCU vendors themselves find with architectures.
Memory is the bottleneck. It affects the cost of the device and the performance and the energy behaviour. And a lot of very low-end devices, such as the LPC8X and the KLO2, have tiny amounts of memory. Just 1 or 2K of RAM, about 8K of ROM. Very significant part of that, almost half of it can be used up just starting up the processor.
Right.
And you have to use the enablement from the semiconductor vendor to do this. You don't have to write your own code to do it. And we can instantly make that significantly smaller. We also support all of the enablement from the semi-vendors, so you can reuse it without any changes. And coping with legacy, moving from older parts and older tools and bringing them to one environment. Okay. Really is so key to using these devices efficiently.
Great. So you've been showing off Somnium DRT here. Can, in a sentence or two, you explain what that is?
So it's really good IDE. We've got really good debug functionality. You actually think about the issues involved in real-time embedded systems. If you want to debug things, you can't break them a lot of the time, so you can access memory without stopping the device. If you've got an electromechanical system, that's really important. You don't have to put any special code into the system to do that, so it hides and bugs. Right. We support all the debug adapters to do that. We also have full compatibility with GNU tools, but unlike the other vendors that just ship vanilla GNU tools, we test them properly, we fix bugs in them. We're going to be having a light level of certification in the very near term for companies how correct the compiler is. And we've got our patented technologies, which we call resequencing, which is compatible with GNU source code. Typically, you can build your software and you will get it around 20% smaller, maybe 20% higher performance, 20 to 50% lower energy. So compatibility with all the enablement from the semiconductor vendors and their entry-level tools, we can automatically import the software with no changes required, and you just get the best possible technical result.
Great. So you have a demo here. Get a little closer. Can you walk us around what's going on here?
Yeah. So we've got a couple of demos here. This one is LPC824 running NXP's gesture recognition demo. My handwriting's not very good. If I draw a number 1 on this, it may work. You can see that the pieces of software here, which are showing in yellow, are accessing variables in memory, and as those values are changing, it's showing what the values are. This is being achieved without breakpointing in the system, without interfering with its behaviour, and it's really great to be able to see real-time data flows going in with no changes required. And we're going to extend this functionality a lot in the future to support wider ranges of facilities and graphing and so on. It works on standard debug adapters we support for segment.
Great. So, last question. You mentioned GNU tools. Do vendors really care about supporting GNU?
I'm not aware of any semiconductor vendor that doesn't have an entry-level tool which is based on GNU, or whose software enablement is not based on GNU. NXP had a huge amount of software enablement for Kinetis and LPC. It's all supported on GNU. Some parts of it aren't supported on non-GNU tools at all, such as the sensor fusion library and intelligent sensor full widely used. If you want to port them to a non-GNU tool, you can do it, but you're on your own, you have to test it using GNU's great. That's why we produced an entry-level product for Freescale now NXP called Kinetis Design Studio. Dart is a great upgrade to that, and then we could also support GNU as well. So GNU is here to stay, and, but it needs to be made tested properly, good features added to it to differentiate it from the free of charge copies.
Perfect. All right, well, Brandon Lewis here, Embedded Computing Design. We're at NXP's FTF. That was Dave Edwards, Somnium. Take care.